Alright. This one we're looking at doesn't use the total sample space. All the other ones we've looked at, we've calculated the total amount of sample space and then done it. This time we're not. There's very specific requirements on what we're going to do. So, the digits 1, 3, 4 and 5 are written on cards, and these cards are then used to form a 4-digit number. Calculate the probability that the number formed is even and then greater than 3,000. So we'll start with the even one. First thing you've got to think of is if the number is even. If the number is even, the last digit has to be an even number. Would you agree?
Yeah.
Cool. Because if it's not an even number at the end, then it can't be even. For it to be divisible by 2, it has to be even. So how many of the cards can actually go in the last place? There's 4 cards.
1.
Yeah. So out of all the results, you know that only 1/4 of them will be even. Can you see why? Sorry? I'm going to assume that's a yes. What about if the number's going to be greater than 3,000? There's still 4 cards that can go in the first place, but how many of those 4 cards will actually work? It's got to be greater than 3,000. Three. Why 3?
Because it has to be greater than 3,000, so... No.
Keep going.
No, because there's only one number, like...
If the 3 was the first number, would any number you did after that be greater than 3,000?
Yes.
So the 3 works. If 4 was the first number, would any number after that be greater than 3,000?
Yeah.
Cool. If 5 was the first number,
Yeah. Yeah.
what about the 1?
No.
So 3 out of the 4 numbers will give you those. That make sense? When you're doing these,